first list. And the way to determine which elements should be included is specified by a function, by a lambda function that we will give it as an argument. And the lambda function will return Boolean value for each of the elements. So if you're familiar with LINK, this is very similar to the where operator. And we'll write a lambda function that returns true only if the number is even. So if we run this bit of code, we will get only those numbers from the input lists that are even numbers. So this kind of working with data that inspired LINK, that's very much based on the functional programming concepts. So let's store the result into a list1 value, and let's use some other function to do some more processing. And this time we will use list.map, which is just like select in C#, and it takes a list of some values. This ''t", that means that the function is generic, and in this case it takes a list of t's and a function that knows how to turn a value of t into a value of u, and the function returns as the overall result a list of u's. So we can, for example, return the square of the number, and we can use a list1 as the input list. So as you can see, now we've got a list which contains squares of even values from the original list that we've created. One thing that's very interesting about functional programming is that whenever you use let binding, it actually means the same thing as if you simply took the initial value and replaced all the occurrences of the symbol, in this case list, with the actual value, which means that the whole program can be actually interpreted as just a single expression. So we can write the code like this, and it will mean exactly the same thing. This, of course, doesn't make the code particularly readable, but we can make it better by using another interesting F# feature, which is called pipelining operator. And the pipelining operator lets us write the code in a more natural fashion as a sequence of some operations that process the input data. So now I've changed the code to use the pipelining operator, which you can see here, and probably even without knowing anything about the operator, you can understand what the code does. It simply takes some input data and then sends this input to the first processing function, which performs some filtering, and then sends this filtered list into the next operation in the pipeline, which is list.map, and which performs some projection of the data. So if I select the code and execute it, it will again give us exactly the same result. And we can of course add some other processing functions to the pipeline, to the sequence of operations. We could, for example, use list.length to count the number of the list elements. So in that case, the result will be 5. So this way of working with data, that's actually very similar to what you already know if you're using LINK in C#, because LINK is heavily influenced by functional programming. And we will use some of the functions that we've seen in this webcast in the next parts, where we will look at working with some actual more interesting data that will come from the RSS feeds. So that's pretty much everything I wanted to demonstrate in this part. We've seen some of the basic functional constructs, such as recursion and using function as an argument, and we've also looked at the functional way of working with data, and in particular at using the pipelining operator in F#. In the next part, we will look at more interesting example because we'll start using some of the .NET libraries to get some more interesting data from the web and then process the.
Now let us get back to some more of the theory. Few interesting facts about the history. During the development of the .NET framework, the class libraries were originally written using a managed code compiler system called Simple Managed C. In January 1999, Anders Hejlsberg formed a team to build a new language at the time called COOL, which stood for C-like Object-Oriented Language. Microsoft had considered keeping the name COOL as the final name of the language, but chose not to do so for trademark reasons. By the time the .NET project was publicly announced at the July 2000 Professional Developers Conference, the language had been renamed C#, and the class libraries and ASP.NET runtime had been ported to C#. James Gosling, who created the Java programming language in 1994, and Bill Joy, a co-founder of Sun Microsystems, the proprietor of Java, called C# an imitation of Java. Gosling further claimed that sort of Java with reliability, productivity and security deleted. Klaus Kreft and Angelica Langer stated in a blog post that Java and C# are almost identical programming languages. Boring repetition that lacks innovation. Hardly anybody will claim that Java or C# are revolutionary programming languages that change the way we write programs, and C# borrowed a lot from Java, and vice versa. Now that C# supports boxing and unboxing, we'll have a very similar feature in Java. Anders Hejlsberg has argued that C# is not a Java clone and is much closer to C++ in its design. How to create an F# script. The following illustration shows the new project dialog box with several available options for F#. The F# library project template is selected.
As you can see, the search items function that we wrote currently returns a list of tuples. Uh, so we create a tuple here. Using tuples, that's a perfectly valid technique in F#. You'll use tuples all the time. But when writing some code that should be used from the C# library, it isn't very comfortable to use tuples. You can of course access tuples, but we'd probably prefer to give the object some type and give it some name that the C# user can see to understand what the code actually means. So we'll start by creating a very simple class that can hold a title and a description of an RSS item. Uh, to write a class, we will use the F# type keyword, and let's call the class feed item. So this is a basic structure of an F# type declaration. To create a class, we can use parentheses here to specify some arguments that the class will take as an arguments of the constructor. So our simple feed item class will take two arguments, and both of them will be of type string. And as the next step, we'll expose these values using two public properties. Uh, when declaring a member of a class in F#, we will use the member keyword, and we'll call the first member a title. And it will simply return the value that we've got as an argument. And let's declare the second member as well. Now the interesting thing about F# class declaration is that we can use the arguments that were passed to the constructor anywhere inside the body of the class. And F# automatically turns these parameters into a private field of the class